Let's talk about one of nature's most powerful and, most mysterious forces. It's something that shapes our entire world, from the absolute smallest quantum particle to the scale of our whole planet. And yet, it does it all in complete silence.
I mean, it is all around you, right now, but you can't see a single thing.
It makes absolutely no sound. It's totally, perfectly silent.
And you can't feel it. But here's the crazy part. Without it, life as we know it it wouldn't exist. So what is this powerful, invisible presence?
We're talking about magnetism, of course, and it all begins with something called the magnetic field. So in this explainer, we're going to peel back the layers on this incredible force, from the absolute basics all the way up to how it protects our entire planet.
Okay, so here's the most important thing to get right off the bat. At its very core, magnetism is all about moving electricity. Anytime an electric charge moves, think of electrons flowing through a wire, it creates a magnetic field. That's the fundamental connection, the handshake between electricity and magnetism.
But hold on a second. That brings up a pretty big question. If a current flowing through a wire creates a magnetic field, what's creating the field in, say, a simple magnet on your fridge? There's no battery hooked up to that. To get the answer, we have to go way, way smaller.
We've got to zoom in, way in, past the material, past the molecules, all the way down to the quantum level, because that is where magnetism is actually born.
And believe it or not, the hero of this entire story is a single, tiny particle, the electron. Every single bit of magnetism you have ever seen or used starts right here.
So check this out. An electron has a negative charge, right? But it also has this bizarre quantum property called spin. Now, it's not literally spinning like a tiny basketball, but you can kind of picture it that way. That combination of having a charge and having spin means that every single electron acts like its own microscopic magnet with its own little north and south pole. And that tiny magnetic field, that's what scientists call its magnetic moment.
So if every electron is a tiny magnet, why isn't everything magnetic? Well, it all comes down to teamwork. In most stuff, like a piece of wood or plastic, all those tiny electron magnets are pointing in totally random directions. They just cancel each other out. But in special materials, like iron, something amazing happens. The spins all line up. And suddenly, all those trillions of microscopic magnetic fields add up to create one big, strong magnetic field that you can actually feel.
And this is super cool because this behavior lets us sort materials into 3 basic groups. You've got your ferromagnetic materials, like iron, and those are the ones we usually think of as magnetic. They're strongly attracted to fields. Then you have paramagnetic materials, like aluminum, which are just weakly attracted. And then there are diamagnetic materials, like copper, which actually repel magnetic fields. It's a very weak effect, but it's there. It all just depends on how their electrons decide to behave.
Okay, so we have this invisible force created by all these electrons getting in line. But if it's invisible, how do we work with it? How do you even begin to map something you can't see?
Well, we came up with a clever idea called field lines. Now, you got to understand, these lines aren't real. You can't touch them. But they are an incredibly useful map. The direction of the lines tells you exactly which way a compass needle would point. And wherever the lines are bunched up really close together, that's where the magnetic field is the strongest. And they always form complete loops, flowing out from the North Pole and looping back around into the South Pole.
And these fields, they do something very specific and kind of weird. A magnetic field exerts a force on any other moving charge that passes through it. It's called the Lorentz force. And get this, it's always a sideways push. It doesn't speed the particle up, it doesn't slow it down, it just pushes it to the side. And that one simple sideways push is the secret behind how electric motors spin, how massive particle accelerators work, and so much more.
All right, let's zoom out. We've gone from the tiniest quantum particle all the way up to an everyday magnet. So what happens if you apply those very same principles to something the size of a planet?
It turns out our planet is a gigantic magnet. Deep, deep down in its core, there's a massive ball of molten iron, just swirling and churning. All of that moving iron creates enormous electrical currents. And guess what those currents do? They generate a colossal magnetic field. And it's not just sitting there. We know from the geological record that this field has shifted, it's weakened, and it has even completely flipped poles many times over our planet's history.
Now this isn't just some neat planetary trivia, it's our protector.
This magnetic field stretches way out into space, creating an invisible shield we call the magnetosphere. Think of it like a force field that deflects the most dangerous, high-energy particles that are constantly blasting out from the sun. Without that shield, solar radiation would have stripped our atmosphere away a long time ago, making life here impossible.
And every now and then, we get to see this shield in action. When some of those solar particles get trapped in the field, they get funneled down towards the poles. As they slam into the atoms in our atmosphere, those atoms release that energy as light, creating one of the most beautiful sights in nature, the aurora.
So, magnetism protects our entire planet. But we didn't just stop there. We learned how to harness it, how to put it to work in ways that have totally revolutionized our world. It really is the silent, invisible engine of our modern lives.
You probably interact with magnetism hundreds of times a day without even realizing it. It's in the electric motors that make EVs go. It's how all that data is stored on computer hard drives. It's the whole principle behind MRI machines that let doctors see inside our bodies. It's in the strip on your credit card, the speakers in your headphones. It is literally everywhere.
And what's so beautiful about all this is the symmetry. A motor takes electricity, uses it to create a magnetic field, and produces motion. A generator does the exact opposite. It takes motion, moves a magnet, and creates electricity. It's this perfect two-way street that lets us convert energy from one form to another and back again. And that brings us to our final, and maybe the most profound idea of them all. We've been talking about electricity and magnetism like they're two related things, but the connection is even deeper than that. They are not two separate forces at all. They're two sides of the same coin. They are two different expressions of a single, unified force of nature called electromagnetism. You literally cannot have one without the other. And this one force governs light, radio waves, X-rays, and the very chemistry that holds our world together. So, from the tiny quantum spin of a single electron, all the way up to the giant shield that protects our planet and the technology that powers our entire civilization, it all comes from the exact same place. The lines of force may be invisible, but their impact, it is absolutely visibly everywhere.